Leetcode problem 2080 rate frequency queries. So let's first try to understand the problem. After that, we'll try to figure out how can we solve it easily. So this is called rate frequency queries. Yeah. So we're gonna design a data structure. So the class gonna be the rate frequency, and we're gonna have the init and the query. So the frequency of a value in a subarray is the number of occurrences of that value in the subarray. Let's try to use an example. For example, this is the subarray. So for example, 1112. So we are going to check. So the query is going to be from the left to the right. So if this is the left and this is the right, and the value is 2, so what is the frequency? It's going to be 1. So what is the value is 1. So the frequency from the left to right is going to be 3 because we have 3 ones. So if we understand it now, let's just continue. So the rate frequency class is going to have the init. So the init is going to be a 1D array. And we also have the query. It's going to be the left and to the right, inclusive for the index. So this is the left index and the right index. And we're going to query this value, and we're going to check the frequency of the value. Yeah, let's just first check this example. So for example, we're going to check from index 1, 2. Yeah. So this is the index 1, and this is the index 2, and we're going to check the value 4, so the frequency is going to be 1, and from index 0 to 11. So for example, this is 0, maybe this is 11, I don't know, but how many? 33. So there are two 33s. So this is 1, and this is another one. So we're going to return a 2. Yeah, but how can we solve this problem? Because the query is going to be 10 to the power of 5, and the length of the array is going to be 10 to the power of 5. And the value is just 10 to the power of 4. This means we cannot solve it by using brute force. Yeah, because basically we can check from the left to the right, and we're going to count how many numbers equal to this value 4 or this value 32. But that's going to be n squared times complexity, because we have 10 to the power of 5 for the array and also for the query. It's going to be 10 to the power of 10. Definitely it will not work. This means maybe we can solve this problem by using n log n time or O(n) time. Maybe n log n time is possible. Instead of checking the frequency of its value from the left to the right, so what about we just take out the values? Yeah, so the idea is very straightforward. So for example, we are going to check this number 33. So why not we just take out the values? So for example, we're going to prepare a dictionary. We have the case 33. And the value gonna be an array, and inside it's gonna be the index for this value 33. So for example, we're gonna have an index 1, and here we're gonna have 2, 3, 4, 5, 6. We're gonna have an index 6, and now we are going to check the left and right. Okay, so for this one, left is 0. Yeah, we can use a binary search to check. Yeah, from the left side with 0. And we can use a bisect right to check what is the number, which is we can use a bisect right to check which number is less than and equal to 11. So we find two numbers. It's going to be 1 and 6, so we're going to return 2. But exactly how can we use this bisect left or bisect right to solve the problem? Yeah, let's just use an example. It's going to still be the same example 1, 6 for this 33. So this is our array, and it has already been sorted because we take the value according to the index. So it's going to be sorted by itself. Now we are going to check this value. We are going to use bisect left and right to check the value with left and right. So currently this left is 0. What we're going to do is that we are going to check a value that is more than and equal to 0. So definitely we can use the bisect left to find the position where from that value it's going to be more than or equal to 0. So this is going to be the left. And it's going to be at index 0. It's going to be pointed to this 1. Yeah, because while we are using bisect left, we're going to check the value which is more than or equal to and we're going to use the bisect left. Inside it's going to be this array. This is array A, and the value is going to be the 0. So we're going to check a value which is more than or equal to 0. Definitely it is this one for the bisect left. So we're going to have an index L. So L pointed to 0 index. Now we're going to use the bisect right to check another value which is 11. So bisect right gonna be this array A with 11. Yeah, so we're gonna check a value which is more than and equal to 11. So which value gonna be more than or equal to 11? This one not, this one not, but it will go out. It's gonna be here. So this is index 0, 1, and this is gonna be index 2. Yeah, because definitely this 11, while we are using bisect right, it's gonna be go out of the array. It's gonna be at position 2. So that this place is going to be 2. So how many values? It's going to be 2 minus 0, so it's going to be 2. So we're going to find 2 values, so we're going to return this 2. So this is the idea of how to solve the problem. Now the problem is going to be really easy. Let's just implement the algorithm. So we're going to prepare a dictionary. It's going to be a default undict. Inside it's going to be a list. Now we're going to check all the values inside of the array with index. So for IV, enumerate the array. So we're going to prepare self.d with this value. For example, currently it is 33. So it's going to append the index. We're going to append it inside. And now we finished our dictionary. And from here, we just prepare another array A. It's going to be self.d with this value. It can be an empty array, or it can be an array with some values. We just need to use bisect left and bisect right to solve the problem. Yeah. So we're going to use the bisect left with this array A and with the value left. And for the right, it's going to be the bisect right with the array A and with the right index. So finally, we're going to return the final result. Yeah. So the final result is going to be R minus L, as I explained earlier. Yeah, because the bisect right will always check the values. So for example, we are having an array 1, 2, 3. While we are using bisect right, if this is 3, for this array is A, while we are using bisect right, it will always go out. So for example, this is the index 0, 1, 2, and here going to be 3. So while we are using bisect left, so for example, we are checking 0, array A with 0, it's going to be the first position. Yeah, because we are going to check the value which is going to be more than and equal to 0. The first value is going to be this 1, so it's going to be ported to 0. So how many of them? It's going to be 3 minus 0, it's going to be 3. Yeah, so it will always work. Now let me just run it to check. As you can see, it works. Now let me submit it to check if it can pass. As you can see, it passed all testing cases and it's pretty fast. And the time complexity is n log n. So this n is how many queries, and the log n is the length of the array A. Yeah, and this array A can be maximum 10 to the power 5. So the final time complexity gonna be n log n. Thank you for watching. See you next time.